W is positive and K increases. On the other hand, if the system does work on the environment, W is negative, and energy of the system decreases. Now, one last thing, and I'll hush up. I don't know how to do this. Somebody want to spot me?
I'll spot you. Good.
Oh, they're going to have to sit right after.
I got you. It's
We
okay.
captured Johnny on film.
Thank you, Luke.
Looks really good.
I'm glad you were off today. I'm sorry.
Why are you off today, Luke?
I think I was I don't know what to say. Look in your book for a minute at the top of page 226, excuse me. All we're trying to do is just finish this one little deal. The equation for work is F equals W equals F times D. Shh. Shh. This is why you fail tests. Don't pay any attention. However, this equation holds only for constant forces exerted in the direction of the motion. The amount of work I do in moving this stapler is the product of the force I apply to it over the distance that I move it. Whether I push it, pull it, or lift it, doesn't matter. It's a constant force that's acting in the same direction as the movement. Force acting up, force acting to your right, left. Is that right?
It's all left, your way.
Whatever. But you know what I mean. What happens if the force exerted is perpendicular to the direction of motion? Well, the example they give is the motion of a planet around the sun, as diagrammed in figure 10.3. If the orbit is circular, then the force is always perpendicular to the direction of motion. Remember from chapter 7 that a perpendicular force does not change the speed of an object, its direction. See, that's why the planet or the ball swinging on a string is accelerating as it goes around the curve, even if it's at constant speed, because it's constantly changing direction. And consequently, the speed of the planet doesn't change. That would be the case in a circular orbit. Unfortunately, planets don't revolve in circular orbits, but we're just cheating a little here. Therefore, its kinetic energy is also constant. Using the equation delta K equals W, you see that for constant K, that delta K equals 0, therefore work equals 0. This means that if F and D are at right angles, then W equals 0. Does that make sense? That's what they're saying. Because the work done on an object equals the change in energy, work is also measured in joules. A joule of work is done when a force of 1 Newton acts on an object over a displacement of 1 meter. An apple weighs about 1 Newton. Thus, when you lift an apple a distance of 1 meter, you do 1 joule of work on it. To put it